40 light-years away, orbiting a faint red star, there's a world that keeps showing up on scientists' most likely to be habitable lists. It's almost the same size as Earth. It's rocky. It sits in the star's Goldilocks zone, not too hot, not too cold, where liquid water could exist on the surface. On paper, this is one of the best bets we've ever found for another life-friendly planet. Its name is Trappist 1e. This is Quantum, where real planets, bold ideas, and hard science meet. Tonight, we're going to visit Trappist 1e, at least with our imagination, and see what scientists actually know about this world and what it would be like if there were oceans, clouds, and maybe even life there. Trappist 1e orbits a tiny star called Trappist 1, an ultra-cool red dwarf in the constellation Aquarius, about 40 light-years from Earth. Red dwarfs like this are small and dim. Trappist 1 is only about 1/10 of the Sun's mass and roughly 1/8 of its radius. It's not much bigger than Jupiter in size, but its mass is compressed into a body only slightly larger than Jupiter. Because it's so faint, its habitable zone is very close in. Earth takes 365 days to orbit the Sun. Trappist 1e orbits its star in just about 6 days. In that time, it travels at a distance of only a few percent of the Earth-Sun distance. Now, for the part that gets astronomers excited, its radius is a little smaller than Earth's. Its mass is a bit lower than Earth's, and its density is similar or slightly higher, consistent with a rock and iron composition. In other words, Trappist 1e is very likely a rocky planet, not a gas dwarf or mini Neptune. It also receives a bit less starlight than Earth does from the Sun, which puts it squarely in the habitable zone for this kind of cool star, especially if it has an atmosphere with some greenhouse gases. On paper, right size, right density, right amount of starlight. This is why Trappist 1e keeps being described as one of the most Earth-like exoplanets we've ever found. At this distance, there's a catch. Trappist 1e is almost certainly tidally locked to its star. That means its rotation period and its year are the same length. Every time it goes once around Trappist 1, it also spins once on its axis. Our Moon is tidally locked to Earth in the same way. We always see the same face of the Moon, but Earth itself is not tidally locked. We spin once every 24 hours, so every part of the surface takes turns in daylight and darkness. Trappist 1e would be very different. On one side of the planet sits in permanent daylight, staring at its red star. The other side is in eternal night, never seeing the star at all. In between is a narrow ring of eternal sunrise or sunset, the Terminator line. If you lived on the day side, the star would hang in exactly the same spot in the sky every day of your life, never rising or setting. On the night side, you'd never see the star directly, only the faint glow of air and clouds carrying heat over the bright hemisphere. Most climate models think the Terminator zone could be the most comfortable place to live, not as scorching as the substellar point directly under the star, and not as brutally cold as the far side. It's a world where time of day is tied to geography. Where you live doesn't just decide your climate, it decides whether you ever see the star at all. Among the 7 Trappist 1 planets, E stands out. Computer models suggest it's the most likely in the system to have retained significant water. It sits in the sweet spot of the habitable zone. Not on the very inner edge like planet D, not on the cold outer edge like planet H. With moderate amounts of greenhouse gases, its surface temperatures could allow liquid water oceans. Teams have even run detailed climate simulations for Trappist-1e, exploring scenarios like an aquaplanet completely covered in ocean, a world with scattered continents under a nitrogen-dominated sky. Snowball states versus warm, partially ice-covered states. Across many of these simulations, Trappist-1e keeps popping up as the best candidate in the system for a habitable, Earth-like surface. On top of that, the star itself is a long-term asset. Red dwarfs like Trappist-1 can burn for trillions of years, far longer than our Sun's 10 billion-year lifetime. If a world like Trappist-1e can hold on to an atmosphere and water, it could have an absurd amount of time for life to emerge and evolve. Now the big question, does Trappist-1e actually have an atmosphere? This is where the James Webb Space Telescope comes in. When the planet passes in front of its star, some of the starlight filters through any atmosphere around the planet's edge. Different gases absorb different colors of infrared light, leaving tiny fingerprints in the spectrum. So far, these observations have told us a few important things. Trappist-1e does not seem to have a thick hydrogen-helium atmosphere like a mini Neptune. Those primordial atmospheres are basically ruled out. The data we have so far points to two broad possibilities: a bare rock with little or no atmosphere detectable from space, or a compact, heavier atmosphere, likely dominated by nitrogen and other heavy gases, potentially with traces of CO or methane. Something more in the family of Earth, Venus, or Titan. The transmission spectrum looks almost flat so far. That can happen if there really is no atmosphere, or if there is an atmosphere, but it's compact, cloudy, and not dominated by hydrogen, which makes special features small and hard to see. Some models that fit the data allow for nitrogen-rich atmospheres with a little methane mixed in. Others prefer a high cloud, high haze scenario, hiding the deeper layers. Critically, no obvious biosignature gases, nothing that screams life, have been detected. We are still very much at the stage of just asking, is there any atmosphere at all? To answer that, Webb needs to watch more transits of Trappist-1e and compare it to likely bare rock neighbors in the same system, so we can subtract out the star's own noisy behavior. If that works, we may finally see whether E really has a nitrogen-rich Earth-style atmosphere, or whether it's just a very pretty, very dead rock. So, putting it all together, a rocky planet similar in size and gravity to Earth in the habitable zone around a star that can shine for trillions of years, with early evidence hinting it might have a secondary atmosphere of heavier gases and no thick hydrogen envelope. On the optimistic side, Trappist-1e could have oceans, continents, clouds, and a nitrogen-rich sky. Its day side might be warm, humid hemisphere under a permanent red sun. Its night side could be a cold, star-lit desert with heat transported there by winds and ocean currents. That's a world where life, at least microbial life, feels entirely plausible. On the pessimistic side, Trappist-1 is an active red dwarf, prone to flares and high-energy radiation. Over billions of years, that radiation can strip atmospheres, especially when planets orbit this close in. It's possible Trappist-1e lost its air long ago and is now a bare, cold rock with only a whisper of gas. At the moment, the data let both stories live, and that's what makes this planet so compelling. Trappist-1e is balanced right on the line between dead rock and second Earth. In the coming years, each new transit, Webb watches, will sharpen the picture. We're not just painting an artist's impression anymore, we're starting to measure what's in the air of a world 40 light-years away. If TRAPPIST-1e turns out to have a dense, stable atmosphere and maybe even oceans, it instantly becomes one of the top places in the galaxy to look for life. If it's bare rock, even that tells us something huge about how fragile habitability is around small, active stars. Either way, this little planet is going to teach us an enormous amount about what it takes for a world to stay alive. In our next episode, we'll zoom out and look at the entire TRAPPIST-1 system. 7 Earth-sized worlds in a tiny cosmic clockwork, and ask a bigger question. If life ever got started there, could it spread from planet to planet? If you've enjoyed this trip to TRAPPIST-1 and want to explore more real worlds that might host life, hit subscribe so you don't miss the next episode. And if this helped you see this little red star system in a new way, consider leaving a like. It really does help more people find the video.